Hello students, how are you all? Very good morning. Today we will be discussing the basics of 8086 microprocessor, or you can say the 8086 microprocessor architecture, means how 8086 microprocessor works. Fine. So first of all, we have to know that 8086 microprocessor is a 16-bit microprocessor. So 8086 microprocessor is a 16-bit microprocessor and it has 16-bit data bus. It has 16-bit data bus. Fine. So we can say it can read data from or write data to memory and its peripheral ports, either 16-bit or 8-bit at a time. It has 16-bit data bus, means it can either read data or write data to the memory and to its peripheral ports, either 16-bit or 8-bit at a time. It has, means 8086 microprocessor has 20-bit address bus. It has 20-bit address bus. AB means address bus. It has 20-bit address bus and can access up to 2 to the power 20. It can access up to 2 to the power 20 memory locations. 2 to the power 20 memory locations means 1 MB memory locations. Fine. Then 8086 microprocessor can support up to 64K input output ports. It can support up to 64K input output ports. And 8086 microprocessor also provides 14 16-bit register. It has 14 numbers of 16-bit registers. It has 14 numbers of total 14 numbers of registers we have, each having 16-bit. Fine. So in 8086 it has multiplexed address and data bus, means it has AD0 to AD15 data and address both are there, means it has multiplexed address and data bus AD0 to AD15 and AD16 to AD19. Fine. So AD0 to AD15 and AD16 to A16 to A19. So it requires 8086 requires single phase clock with 33%. It has single phase clock with 33% duty cycle to provide internal timings. जो टाइमिंग्स एंड कंट्रोल में होता है वो 33% उसका ड्यूटी साइकिल्स होता है. Then 8086 microprocessor can prefetches up to 6 instruction bytes, from memory. Fine. So 8086 microprocessor supports two modes of operation. It supports two modes of operation. One is minimum mode, another is maximum mode. So in 8086 we have two modes of operation. One will be minimum mode, another will be maximum mode. Fine. So in 8086 architecture, now I am erasing all these things So in 8086 microprocessor as shown in this figure, so its CPU is divided into two independent functional blocks. One is BIU, bus interface unit, BIU. Another is execution unit, that is EU, execution unit, and bus interface unit. Fine. So in 8086 architecture, the execution unit, this part, execution unit, this execution unit of the 8086 tells the bus interface unit where to fetch instructions or data from memory or decode instructions and execute instructions. The execution unit of 8086 decides where to fetch instruction, where to decode instructions, and where to execute instruction. The execution unit contains the control circuits or the control unit, you can say control circuitry, which directs internal operation of the 8086. Fine. Say a decoder in the execution unit translate instructions fetched from the memory into the series of actions. Fine. So this execution unit has a 16-bit arithmetic and logical unit ALU. It has 16-bit ALU which can add, which can subtract, which can do AND operation, which can do OR operation, which can do XOR operation like this, increment, decrement, and complement or shift binary numbers, all these things. Fine. So the main function of EU means execution unit. You can say the main functions of execution unit are decoding of instructions, execution of instructions. Fine. So the main function of the execution unit is to decode any instructions and execute any instructions. Fine. And the bus interface unit sends out addresses, fetches instructions from the memory, reads data from different input-output ports and memory, and write data to output ports and memory. Fine. So in simple word, you can say the bus interface unit of 8086 handles all transfers of data and addresses on the buses for the execution unit. In simple words, the bus interface unit can handle all transfer of data and addresses of the buses for execution unit, that is E. Fine. So in 8086 architecture, we have one advantage. In 8085 microprocessor, we did not have any pipelining concept. Now, the one main advantage of 8086 microprocessor is that it has pipelining architecture. It has pipeline concept. That is why 8086 has come after 8085. It was the first typical advantage of 8086 found. Fine. So what is actually pipelining concept? While the execution unit is decoding an instruction or executing an instruction which does not require use of the buses, the bus interface unit fetches up to 6 instruction bytes for these instructions. Fine. So bus interface unit stores these prefetched bytes in a first in first out register set called the queue. First in first out. first in first out register is known as Q. Stack was last in first out. Stack में क्या होता था, जो लास्ट में इन होता था वो फर्स्ट में आउट, ठीक है. और क्यू में क्या है, लास्ट इन फर्स्ट आउट, जो फर्स्ट में आएगा वो पहले जाएगा, ठीक है. When the execution unit is ready for its next instructions from the queue in the BIU, this is much faster than sending out an address to the system memory again and again and waiting for the memory to send back to the next instruction byte or bytes. Fine? Except in the case of the jump operation, jump instruction or call instructions, where the queue must be dumped and then reloaded starting from the new addresses, the prefetch and the queue scheme greatly speeds up the processing of the 8086 microprocessors. That was the basic advantage of 8086 microprocessor after involving the pipelining concept. So fetching the next instruction while the current instruction is executes is called the pipelining. You can say in simple words, fetching of the next instruction while the current instruction executes. एक इंस्ट्रक्शन एग्जीक्यूट होते होते ही नेक्स्ट इंस्ट्रक्शन को जो फेच डिकोड कर लेता है वही पाइपलाइनिंग कॉन्सेप्ट है. सो फेचिंग ऑफ नेक्स्ट इंस्ट्रक्शन व्हाइल द करंट इंस्ट्रक्शन इज स्टिल एग्जीक्यूटिंग इज कॉल्ड द पाइपलाइनिंग. फाइन. सो वी हैव टू नो द बेसिक रजिस्टर ऑर्गेनाइजेशन in case of 8086 architecture also. So in 8086 has a very powerful set of registers known as the general purpose registers and special purpose registers. General purpose registers and special purpose registers are also there in 8085. But here different modifications are done with 8085 so that the speed of the microprocessor can be increased. Now in 8086 architecture we have arranged or we have designed our register pairs so that the speed of the microprocessor can be increased. This is our first condition. Fine. So all of these registers in 8086 has 16-bit registers. All the registers you can find in the architecture will be of 16-bit registers. So we have general purpose registers. So general purpose registers can be used as either 8-bit register or 16-bit registers. They may be either used in holding data or holding variables or holding immediate results temporarily or for other purposes like the counter or for storing offset address for some particular address moves. Fine. And the special purpose registers. So special purpose registers are basically used in 8086 as different segment registers. Different segment registers or different pointers or different index registers or as offset storage registers for the particular addressing modes. Fine. So 8086 register, you can say in simple words, 8086 registers can be classified into different types. One is general data registers, one is segment registers, one is pointers and index registers, and another is flag registers. Flag you can find here, flags. So flag registers. Fine. So in general purpose registers, we have AH, AL. H means high, L means low. So AH, AL, BH, BL, CH, CL, DH and DL. Fine. So means if we take the 16-bit, we can make the pair as AX, BX, CX, DX like this. So we have 4 pairs AX, DX, BX, CX, or we can use 8-bit. So we can take AH, AL, 8-bit, total 16-bit, BH, BL, total 16-bit, CH, CL, total 16-bit, DH and DL, total 16-bit. Fine. We have four number of segment registers. Here you can find segment registers. All these are segment registers. ES, DS, CS, SS, all are segment registers. Fine. Then we have flag resistors. We also have 4 types of special resistors which are known as pointers or index resistors. One is SI, one is DI. These are index resistors. SP you know, BP, base, pointer, like this. I'll explain all these. So we have pointers and index resistors, SP, BP, SI, DI. Another pointer resistor is here, IP. So we have basically pointers and index resistors are basically 5. SP, BP, SI, DI and IP. Fine. So first of all we will be discussing different general data resistors. So the resistors AH, AL or together AX, BX, CX, DX are the general purpose 16-bit resistors. AX used as the 16-bit accumulator. Lower 8-bit is designated as AL and higher 8-bit is designated as AH. AL can be used as an 8-bit accumulator for 8-bit operation and AH can be used as an 8-bit accumulator for any 8-bit operation. So all data resistors can be used as either 16-bit or 8-bit. BX, for example, BX is also a 16-bit resistor, but BL indicates the lower 8-bit of BX and BH indicates the higher 8-bit of BX. Fine. So the resistor BX is basically used as offset storage for forming physical address in case of certain addressing modes. The resistor CX is used as the default counter in case of string and loop instruction. CX is used as default counter in case of string and loop instructions. And last, DX or DH, DL, either DX, DH or TL or in together DX, 16-bit resistor, the general purpose 16-bit resistor which may be used as an implicit operand or designation in case of a few instructions. Fine. So it is basically used as the implicit operand, implicit resistors or implicit operand resistors. Fine. So we have 4 type of segment resistors. One is code segment CS, another is data segment DS, another is extra segment ES, extra segment, another is stack segment resistor SS. So we have extra segment, we have code segment, we have stack segment and we have data segment resistors. Fine. So this comes under segment resistors, means in 8086 we have 4 segment resistors. Fine. So these are basically used for segmented memories. 8086 able to address a memory capacity of 1 megabyte, 1 megabyte, and it is byte organized. 8086 is always a byte organized microprocessor. This 1 megabyte memory is divided into 16 logical segments. Each segment contains of 64 kilobytes of memory. Code segment register is used for addressing memory location of the code segment. Data segment register points to the data segment of the memory where the data is stored. Extra segment register also refers to the segment of the memory which is another data segment in the memory. Stack segment register is used to addressing stack segment of the memory. This stack segment is that segment of memory which is used to store stacked data, stacked format data. Fine. So while addressing any location of the memory bank, the physical address is calculated first. Fine. So physical address is calculated first. So physical address we can write what? Physical address we can write segment address plus offset address. Segment address plus offset address we can write what? Physical address. It is very important. to calculate the physical address. So to know the physical address, you should know the segment address plus offset address. The first segment address, the segment registers contain 16-bit segment base addresses related to different segments of the 8086 architecture, and the second part is the offset value of that segment. Fine. So now we have pointers and index registers. So pointers and index register, how many we have in 8086 pointers and index register? We have 5. 1, 2, 3, 4 and 5. Fine. So first index register is IP. IP is instruction pointer store memory location. So IP, the full form of IP, you can say instruction pointer. Fine. So the instruction pointer stores memory location of next instruction to be executed. Because 8086 architecture works on the principle of pipelining now. When one instruction is being executing, another instruction is fetching and decoding. So obviously the instruction pointer store memory location of the next instruction to be executed. Fine. And BP, where is BP? Here, BP will be our base pointer, SP will be our stack pointer, SI will be our source index, DI will be our destination index. Fine. The pointer registers contain offset within the particular segment. The pointer register IP contains offset within the core segment. The pointer registers BP contains offset within the data segment DS. The pointer register SP contains offset within the stack segment SS. Fine. The index registers are used as general purpose register as well as for offset storage in case of indexed, base indexed or relative base indexed addressing modes. So register SI, here it is, register SI is used to store the offset of source data in data segment. The register DI is used to store the offset of destination of the data or the extra segment. So SI is used to store the offset of source data in data segment, and DI is used to store the offset of destination in data or extra segment ES. The index registers are particularly useful for string manipulation. Fine. So index register, all these index registers are basically useful for any string manipulation. So now means general purpose registers done, then different segment registers done, then different pointers and index registers done. Next will be what? Next will be our flag registers. So flag registers are here. So 8086 means 8085 has 5 flags. So in addition with the 5 flags, another some flags will be coming in case of 8086 register. The basic operation of the flag register will be same. The basic operation of the flag register will be same. Fine. So 8086 flag register indicates the result of the computation in the arithmetic and logical unit. Mean it also contains some flag bits to control the CPU operations. Fine. So a 16-bit flag register is used in 8086 because 8086 itself is a 16-bit processor. So flag register cannot be 8-bit. So in case of 8085 flag registers were 8-bit D0 to D7. Now flag register should be of 16-bit because it is used in 8086 architecture. Fine. So a 16-bit flag register is used in 8086. So now flag registers are also divided into two parts. One is what? One is condition code or status flags. Number 2 is machine control code. First code is status flag or conditional code. Second is our machine control flags. So conditional flag register is the lower byte of the 16-bit flag registers. 16-bit flag register में lower byte जो होगा वो conditional flag register होगा. The condition code flag register is identical to 8085 flag register you can say. So 8086 8085 में जो flag registers थे वो ही flag registers 8086 में भी है, उसका नाम अलग से दे के रखा है क्या, condition code flag register. Fine. So with an additional means overflow flag means और एक फ्लैग है overflow flag. So overflow flag को लेके और 5 जो फ्लैग था साइन फ्लैग, जीरो फ्लैग, कैरी फ्लैग, ऑक्सिलरी कैरी फ्लैग, ये सब जो था वो यहाँ पे आ जाएगा, कंडीशनल फ्लैग के अंदर में आ जाएगा. और फ्लैग्स आर ऑफ टू टाइप्स, वन वाज कंडीशनल, अनदर वाज कंट्रोल फ्लैग रजिस्टर. So control flag register is the higher byte of the flag register. So control flag register will be higher byte of flag registers. So in 8085 we had sign flag number 1, zero flag number 2, parity flag number 3, carry flag number 4, auxiliary carry flag number 5. Now in case of 8086 number 6 will be added as overflow flag. 6 नंबर फ्लैग क्या होगा, ओवरफ्लो फ्लैग, OF. उसको क्या नाम से बुलाया जाता है, OF. OF मीन्स ओवरफ्लो फ्लैग. नेक्स्ट क्या आएगा, ट्रैप, TRAP, ट्रैप फ्लैग. उसको क्या से बुलाया जाता है, TF, ट्रैप फ्लैग. फिर क्या आएगा, इंटरप्ट फ्लैग, IF, इंटरप्ट फ्लैग. फिर क्या आएगा, डायरेक्शन फ्लैग, DF और D. ठीक है, कुछ किताब में DF से है, कुछ किताब में D से भी है. D मतलब फ्लैग में 8086 का फ्लैग में D मतलब डायरेक्शन फ्लैग और DF मतलब डायरेक्शन फ्लैग. तो साइन फ्लैग तो हम लोगों के पास पहले ही था. साइन फ्लैग, जीरो फ्लैग, पैरिटी फ्लैग, कैरी फ्लैग, ऑक्सिलरी कैरी फ्लैग, और दे आर इन 8085 also. Now in 8086 also we have sign flag, we have zero flag, we have parity flag, we have carry flag, we have auxiliary carry flag. Then next we have overflow flag, trap flag, interrupt flag, direction flag. Fine. So the basic structure of the 8086 flag, if you draw, or better the explanation of the 8086 flag registers. So we have flag register configuration for 8086 as this. Fine. So 0 to 15 means 8086 flag register are of 16 bit. Fine. So 15, 14, 13, 12 are undefined or unused bits. 5, 3, 1 are also unused bits. So we have at 0 place we have carry flag, parity flag, then AF is auxiliary carry flag, then we have ZF, zero flag, sign flag, trap flag, interrupt flag, direction flag, overflow flag. Fine. So it is our carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, direction overflow flag, or in and 11 we have overflow flag. Fine. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 flags. So in 8086 we have total 9 flags. So first comes sign flag, SF. So sign flag. So this flag will be set to 1 when the result of any computation is negative. For signed computation, the sign flag equals to the MSB of the result. Fine. For zero flag is set to 1 if the result of the computation or comparison performed by the previous instruction is 0. Then parity flag, PF is parity flag. So parity flag is set to 1 if the lower byte of the result contains even number of ones. Then carry flag, CF, carry flag. So CF is set when there is a carry out of MSB in case of addition or a borrow in case of subtraction. Fine. And auxiliary carry, auxiliary flag, we have written AF, auxiliary carry flag ACF or AF. Fine. So auxiliary carry flag is set if there is a carry from the lower nibble, that is bit 3 during addition or borrow for the lowest nibble, bit 3 during subtraction, like this. Then we have overflow flag. We have overflow flag, OF, overflow flag. So listen carefully, these flags are new flag. Overflow flag, this flag will be set if an overflow occurs. This flag will be set if an overflow occurs. That is, if the result of the sign operation is large enough to accommodate in the destination register. The result is of more than 7 bits in size in case of 8-bit signed operation and more than 15 bits in size in case of 16-bit signed operation, then the overflow will be set. Overflow occurs if the result of a signed operation is large enough to accommodate in a destination register. Fine. Then we have trap flag, TF, trap. It is TRAP, trap flag. So this trap flag is set. The processor enters the single step execution mode. The processor executes the current instruction and the control is transferred to the trap interrupt service routine. Because ट्रैप जो इंटरप्ट होता है वो बहुत इंपॉर्टेंट इंटरप्ट होता है. मतलब जब ट्रैप सिग्नल आएगा, जो ऑपरेशन तुम्हारा प्रोसेसर में था वो स्टॉप हो जाएगा, ट्रैप को देगा, ट्रैप एग्जीक्यूट हो जाने के बाद वो ऑपरेशन फिर से चालू हो जाएगा. ठीक है. सो व्हेन दिस ट्रैप फ्लैग इज सेट, द प्रोसेसर एंटर्स into a single step execution mode. Means it will stop executing the current instruction, rather it will execute the trap instruction first. Then after execution of the trap instruction, again the same instruction, means the previous instruction will be executed. Fine. Then we have interrupt flag, IF. We have interrupt flag. So it is, this interrupt flag will be set when there will be some maskable interrupts. Maskable interrupts मतलब जो तुम skip नहीं कर सकते हो. Unskippable interrupt जो होता है वो maskable interrupts होता है. ठीक है. CPU जब देखते हैं कि कोई भी maskable interrupts आ गया है तो interrupt flag को set कर देता है, मतलब उसको 1 बना देता है. ठीक है. फिर we have direction flag. Then we have direction flag, or you can say string direction flag. In some books it is written string flag or string direction flag. Fine. So this string flag or string direction flag or simply direction flag is used by string manipulation instructions. If this flag bit is 0, the string is processed beginning from the lowest address to the highest address, that is auto incrementing mode. Or if this string flag or direction flag is set to 1, not set to 0, the string is processed from the highest address towards the lowest address, means auto decrementing mode. When this flag is set to 0, it will be auto incrementing mode. When this flag is 1, it will be auto decrementing mode. Fine. So means these were all about the flag registers of 8086. So 8086 has total 9 number of flags. So carry flag, parity flag, auxiliary carry flag, sign flag and zero flag were there in 8085 also. So in addition to these 5 flags, we have trap flag, we have interrupt flag, we have direction flag or string direction flag or string flag, or we have overflow flag. Fine. So these are all about the flag register of 8085. Another thing will be very important in case of 8086, that the physical address calculation is very much important. Physical address calculation means how you should calculate the physical address. Fine. So for example, it is an example that if the segment address is say 1005H, segment address we have chosen 1005H. If its offset means offset address, if its offset address say 555H, 555H, 5555H, 5555H. So we have segment address as 1005H, offset address as 5555H. So segment address is 1005H, means 1005 means it will be 0001, then 0000, then again 0000, then 0101. It will be 1005H hex. So now shifted left by 4 position. Shifted लेफ्ट बाय 4 पोजीशन, अगर हम उसको लेफ्ट में 4 पोजीशन इसको लिखे तो उसको क्या लिख सकते हैं 0001 0000 0000 नो 0101 and then 0000 इसको इधर ला दिया हमने, ठीक है। शिफ्टेड लेफ्ट बाय 4 पोजीशन हमने कर दिया, शिफ्ट कर दिया। नाउ ऑफसेट एड्रेस वाज 555H 555H, that was our offset address, means it will be equivalent to what? 5 means 0101, again 5 means 0101, again 50101, again 50101. Fine. Now we have to add these two numbers. We have to add these two numbers so that to get the physical address. We have to add these two numbers so that we can have the physical address. So the physical address will become what? 155A5H 155A5H. Our physical address will be this, means it will be in binary, it will be equivalent to what? 0001, it is 1, 0101, it will be 5, again 0101, it will be 5, means A means 1010, fine, then again 5, so 0101, fine. So means we got physical address is equal to segment address segment address into 10H, see, into 10H plus offset address. Offset address ये फॉर्मेट में हम लोग आएगा कि physical address. How to calculate physical address? If you know the segment address, multiply it by 10H plus offset address. So segment address into 10H plus offset address, you will be getting the physical address. Fine. So this is how we can calculate the physical address. Any physical address can be calculated as this method. Fine. So the main advantages, you can say the main advantages of the segmented memory scheme in 8086 will be, means why 8086 uses the segmented memory scheme. So that sort of question may ask. Then simply we will write what? That 8086 uses the segmented memory scheme because it allows the memory capacity to be 1 megabyte, 1 MB. Although the actual address to be handled are of 16-bit size. 8086, the total means actual address to be handled is 16-bit size, but the memory capacity to be 1 MB. And also we used the segmented memory in 8086 because it allows placing the code, data or stack portions of the same program in different parts or different segments of the memory for data and code protection. And also in 8086 we have 8086 permits us a program or its data to be put into different areas of memory each time the program is executed. That is, there is a provision of relocation. There is a provision of relocation. That is why the segmented memory scheme is always used in 8086 architecture. Fine. So also you have to learn different addressing modes of 8086 also. So unlike the addressing modes of 8085, so you have to learn different addressing modes of 8086 also. So typical questions may be asked. So here also we have immediate addressing mode, we have direct addressing mode, we have register addressing mode, we have registered indirect addressing mode, we have indexed addressing mode, new addressing indexed addressing mode, we have register relative addressing mode, we have based index addressing mode. Fine. We have relative base indexed addressing mode. So we have 8 addressing modes in 8086. What was that? First is immediate addressing mode, second is direct addressing mode, third is register addressing mode, fourth is register indirect addressing mode, fifth is indexed addressing mode, sixth is register in relative addressing mode, seventh is base indexed addressing mode, 8 will be relative base indexed addressing mode. Fine. So for forming different effective address, how the direct addressing mode or register indirect or relative addressing modes comes into picture, or how do you calculate the physical address using the segment address and offset address for different addressing modes, means different shifting segment address. So shifting different means here we have shifted left by 4 position now. So in case of direct addressing mode, register indirect or register direct or base indexed or relative base indexed, how do the physical address gets changed, or how do you change the segment address and offset address? That will be also required for your examinations, and you can find the different formulas of calculating the physical address in different addressing modes or details of the addressing modes of the 8086 in the description of this video. So in the description you will be getting the PDF of that, so that you can prepare for your exams. Fine. Thank you all.